Welcome to Maths for You channel. A past question on projectile mechanics. A particle is projected from a point on a horizontal ground at an angle alpha. Alpha is between 0 and pi by 2 acute angle to the horizontal, the angle to the horizontal, with initial speed of u is equal square root of 2gr, where r is the horizontal range of the projectile on the ground. Show that the angle between the two possible initial direction of projection is pi by 3. So it's a simple projectile, and the initial velocity is u square root of, I just put a sketch, u square root of 2gr, and the angle to the ground is alpha. Alpha is an acute angle between pi by 2 and 0, but there can be, as the questions suggest, there will be two direction to get the range of r. R. So we need to find that between those two angles is pi by 3, 60 degrees. So we're looking for two values for alpha, two or more values for alpha. Let's see how we do it. Right. The initial velocity u is square root of 2gr with an angle of alpha. That can be separated for a horizontal direction and vertical direction. Is a vector, of course. So the horizontally, u cos alpha, u times cos alpha. Vertically upwards, u sine alpha. Using a Surratt equation, the Newton-Surratt equation. The equation which we are using it is S equal ut plus half at squared. Horizontally, I should put the little arrow there, horizontally we're using. Horizontally, there won't be any acceleration or the rate, the velocity wouldn't change. So therefore, A equals 0. So the equation become S equal ut. So S is the range R that's been given, and U is the horizontal velocity, is square root of 2gr cos alpha time t. T is the time taken to the particle to reach the ground again. So R t equal R over square root of 2gr cos alpha. So let's keep that. Then we can use that vertically. As you look at it vertically, the particle actually go above the ground and come back to the ground. So if you, after it's reached the ground again, the vertically displacement is 0. So again, we're using that S equal ut plus half at squared. So the height or the actual distance travel, a total distance travel is actually left the ground and reach the ground again. So 0, that is 0. And the direction is y. So 2gr sine alpha, that's the initial velocity u vertically, and t minus half the A equal g, the gravity. A equals g t squared. So t from this, we can take t out. T cannot be 0 because of the particle actually left the ground and travel for time and come back. So it cannot be 0. The 0 is initial stage. If it's answer, 0 is initial stage. So what we are looking for, not equal 0. So the t not equal 0. From that, we can work out, do a bit of algebra. We can work out t equal 2 square root of 2gr sine alpha over g. That is, okay, if we look at this one is 1. And we found a t equal this one. Therefore, we can substitute the value for t. So in other words, we want to eliminate t on that equation 1. So equation 1 is T equal R over square root of 2gr cos alpha. If we could substitute that for T, so R over square root of 2gr cos alpha equal, and from the second equation, that is T again, 2 times 2gr sine alpha or G. So you do some a bit of calculation. So if you cross multiplication, RG cross multiplication, left hand side, RG, R times G is RG. And if you do the other way, from the denominator from the left hand side to denominator to the right hand side, 2, and square root of 2gr, square root of 2gr become just 2gr, the square root removed. And then again sine alpha, then cos alpha here, sine alpha times cos alpha. So RG cancelled out both sides. So the left hand side is 1 equal 2 times 2 sine alpha cos alpha. We should know, the students should know, 2 sine alpha cos alpha is a standard trigonometric format, is sine 2 alpha. So we can use that 2 sine alpha cos alpha is sine 2 alpha. Then if you could keep the 2, that sine 2 alpha equal half. So sine 2 alpha equals half. Again, students should know this the prime value for alpha or 2 alpha when sine 2 alpha equal half. That is pi by 6, sine 30 equal half. So 2 alpha is pi by 6. We use the Ural format because of this is the value for sine 2 alpha, but sine 2 alpha can take many values, but we don't need many values. But yeah, use the general format. The sine, the general format for sine is theta equal n pi plus minus 1 to the power n sine inverse half. This just a normal the standard equation. So n equals 0, 2 alpha equal pi by 6, which is the prime value which we have found. From that, alpha equal pi by 12. So it's one value for alpha is pi by 12. The next one, n equal 1, 2 alpha again, n equal 1. So n times pi is 1 pi plus minus 1 to the power 1 pi by 6, which will be is pi minus pi by 6. That will be 5 pi divided by 6. Again, alpha equal 5 pi by over 12. What they ask the question between there are two values. See whether these two values are acute angle between pi by 2 and 0. Yes, the pi by 12 is 15. It's less than 90. So again, this 5 pi by 2 is 75. Again, it's less than 90 and greater than 0. If you do any more value for n, that will go out of that, the alpha will be greater than pi by 2, which we don't want. So we just want to keep that this given alpha is acute angle. Therefore, these two values, pi by 12 and 5 pi by 12, are the two angles. But the question asks, between these two angles is pi by 3. So 5 pi by 12 minus pi by 12 equal LCM 12, and 5 minus 1 is 4. And then again, 4 common, pi by 3. So that is what we have been asked to prove. S is initial value that R is a range and projectile on the ground. Show that the angle between the two possible initial direction of projection is pi by 3. That is 5 pi by 12 minus pi by 12 is pi by 3. So that's the answer we are looking for. Thank you. Please subscribe the channel and share the contents with other students and friends. If anybody wanted to sort of justify it, say just put n equal 2 and see 2 alpha, how much 2 alpha will be. Is it still be acute angle? No, it's greater than 90. Therefore, I haven't, therefore, that is why I haven't taken it further than n equal 1. You can work it out and just to justify yourself. Thank you.